Tech Nuggets, VyOS and GNS3, Part 2. Just a quick review of resources. The link here and in the show notes is the user guide for VyOS. Super useful. Highly recommend that you keep it open while we're working with the VM, or you're working with your own VM to follow along with any of the commands that you might need. It's the resource that I use when I need to look up commands on how to work with it. Network diagram is also linked in the show notes. We talked about it in the previous video. It's the diagram that we'll be working from. It has all the IP addresses on it. Very useful stuff. On to VMs. All right, so here we are back at our VM, or VMs plural if you're into recursive VM language. Hopefully you've had a cup of coffee and a nice break and a chance to stretch your legs. So moving into this, we will go back and have a look at VyOS 1 as we did commit the changes, and you can see here that the little plus is gone. We did commit them, but that's not the same thing as saving it to the disk. So if we were to have a power outage on VyOS 1 right now and it were to reboot, the changes that we made would not be persistent. They would not persist through a reboot. So when we type them in and hit enter initially in the command goes in and it is processed, and we get the little plus which says yes, the command processor accepted it, and we type commit to actually implement the change on the current running system. So in other parlance, that would be it's in the running config, so it's running as of right now. But that's not in the saved config, so if VyOS 1 were to reboot at this moment, we would lose all of our changes, and sometimes that matters and sometimes it doesn't. So earlier we did commit to commit it, now we'll do save, which will turn around and save it to the config.boot file, and were we to reboot the router now, it would come up and have all the changes that we've made to date. And the reason it's done this way is so that way if we implement commands that accidentally cut off our own nose, we can't save them. So if you were to SSH into this and then configure it in such a way that turns off SSH, the minute you hit commit and it shut off SSH and kicked you out, you wouldn't be able to type save to save that. And the way you'd get out of it is to go and reboot the router, and ta-da, it would come back with whatever it had previously. So that's kind of why that works that way, so that remote access to the system is more difficult to cut your nose off. It is absolutely possible. It's just more difficult. All right, so let's go on and talk a little about saving in VPCS, because that's also something you might want to do. And you can see here on the screen it says save and file name. So we'll say save, and we'll say VPCS-1. And there it is. It saves it to a VPCS file. And were it to reboot, we could say load, and we would say load VPCS-1, and it will load that. That's all it does. It saves the settings and loads the settings, and it makes it easy, and that way we can shut it down for the day and bring it back and do all that kind of stuff. It's kind of a basic get there from here. All the different VMs and sessions that you use in GNS3 often have this kind of thing because they're based on real-life pieces of equipment that we're going to want to do. All right, so let's move on and have a look at the other side of the router. So we'll go back to VyOS 1. And earlier we talked about ETH0 and how it was going to need some changes. So if we do a show command, we can see here that ETH0 is already set up, but it's not set up in a way that we need. By looking at our diagram, you can see that it should be or will be set up with ETH0 as 192.168.103.125. But right now it's set up for DHCP. DHCP's often useful, great way to come out of the box that way, but for our purposes we need it to be reconfigured to be a static IP. So the first thing I'm going to do is I'm going to go set interfaces ETH0 address, and then we're going to set our address just like I did before, 192.168.103.125/24. And now when we do a show, now you can see it's got two address lines. One's DHCP and one is my static. Now, the truth is, an Ethernet card can have multiple IP addresses, and we often do. They'll have 4 or 5 or 10 addresses on one Ethernet card. It is not a one-to-one relationship, nor does it need to be. In our situation, we don't want DHCP. There's no DHCP server in our setup right now, but if one were to pop on there somehow, it would suck up an address and be confusing. So in this case, we're going to say delete instead of set, and the command's going to work pretty much the same way. Interfaces, Ethernet, ETH0, address, DHCP. So now when we do the show, we can see there's a minus for the address line for DHCP and a plus for the address line for our static. Now, we talked earlier about the differences between what happens when I hit enter on the command line and then when I do a commit. We haven't committed any of these changes. We're just looking at them in the command, running memory of the config file. So that way we can see exactly what's going to be removed and added. So if I type commit, this will actually implement those changes. And we do show, and you can see now ETH0 has the IP address and has removed DHCP. And that's great. That's what we want. At this point, VyOS 1 is pretty much configured on the interface level. VPCS is configured on its interface level. We haven't touched the route table, but we will. Let's get all of our machines configured with IP addresses and get all the interfaces up and everything like that. And then we'll come back and start talking about routing, and that'll get the two routers to talk to each other, and traffic can go from VPCS to the server. So we'll go through, I will do a speed version and go through and configure all these things, and that way you can see what's going on, but I'm not going to go super slow as we go. It will be the same steps that I just used in the other the other router and the other VPCS. All right, so let's go configure the other side. So you can see here we've got our usual running, and I'm going to bring up VyOS 2, and I'm going to bring up server, and server's already configured. And it looks like we saved server here to server VPC, so that way we can load it if we need to. So it's 54.100, which is great. So we need to go and usually the first thing I do when I sit down at a router is run the config command because I want to see what's going on. So we can see here VyOS 2 looks pretty blank, the standard way we expect it to look. So let's do our config commands. Set interfaces ETH0. So we'll start with ETH0, and its address is 192.168.103.100/24. And we're going to remove. And all I did was use the up arrow key to get that command back, and I used the home button to kick me all the way back to the beginning of the line, and I can use the end button to kick me all the way back to the right side again, so it makes it a little easier. Keyboard shortcuts become your buddy after you do it for a while. And you can see I've got the plus there and the minus there in the right order, and we'll do the other command. You don't have to do these 1, 1, 1. You can stage it all and do it all at once. The problem is when it blows up and doesn't work, you don't know which one died. So we tend to do them in little groups of commands. So again, I'm going to do the set interface command, and we're going to do this for ETH1. So 192.168.54.254/24, and there we go. You can see I'm removing DHCP and I'm adding the two static IP addresses, and we do a commit, and we do a save, and that way if things reboot, we can still get back to them. We should be able to ping from here to 54.100, right? 54.100, which should be server. Ta-da! There we go. Ping, ping, ping. We're pinging from VyOS 2 through switch 3 to server. All right. So at this point, we've got all four of our machines, two routers, two clients set up and configured. But you can't go from the server to the VPCS, and you can't go from VPCS to server. So if I were to go and try to do that kind of thing, here's VPCS, and I say, well, I really want to ping 192.168.54.100, right? That's the IP address of server. It will say, gosh, I don't know how to do that. I can't get there. And that's what that's telling you is destination unreachable is meh. I don't know where that is. So it's the VyOS 1 is returning an error back to that says, I don't know what to do with this. And we've told VPCS, if you don't know what to do with the traffic, take it to VyOS 1 and they'll deal with it. And VyOS 1 looks at the traffic and says, I don't have anybody I can hand this to. That's where the route table is going to come in. We're going to go next and configure VyOS 1 to be able to find the remote network that server lives on. All right? It's not a directly connected network that VyOS 1 is part of. VyOS 1 is part of two different networks, but it's not part of the network that server is on. So we're going to tell VyOS 1, if you see traffic for that network where server lives, here's what to do with it. And we'll do that next. So in between video segments, I was watching them and I realized that I had made a mistake. I had not gone in and configured VyOS 1 ETH0. So that had no IP address on that Ethernet card. So I apologize if you were watching earlier and you're like, you didn't configure ETH0. What's going on? It's my mistake. I've corrected here, as you can see. One of the easiest tests that I should have followed, it's my own best advice, is to ping all the different segments of your network to make sure they work. So ping between VPCS 1 and VyOS 1 in that network and make sure it works. And in this case, I'm going to ping between VyOS 1 and VyOS 2 to make sure they do what they should do. And you can see here I'm pinging 192.168.103.100, which is the IP address that VyOS 1 and VyOS 2, they're both on the 103.0 network. And you can see that it pings back and forth. This is something I should have done myself and just missed it as we went along. All right, well, it occurred to me that one of the true joys of GNS3 we're going to use here to actually prove the packets aren't making it from VPCS 1 to server. And the joy here is that we can use Wireshark and packet sniffing to see things. Now in the physical world, we'd have to, unplug and plug a sniffer switch in between the two devices, or we'd have to configure a mirror port on one of the switches, which is kind of a more high-end feature of a more expensive switch. But in GNS3, since it's all software, we can right-click once it's red like that, and we can say, start sniffing, and it will start a capture for us. Sometimes it'll start Wireshark and sometimes it won't. So when it doesn't, you can see the little magnifying glass. You can right-click on it again, and you can say Start Wireshark. Now, in this context, Wireshark is merely viewing the packets that are being captured. So some of the features that we use in Wireshark in a physical world, especially this restart sniff, they don't work so well. So we have to do some other things like physically right-click on it and say Stop Capture when we want it to go and stop the capture. That's why there's two different options here. So please be aware of that. In the real world, Wireshark is capturing and displaying. In GNS3, it is only displaying. And we're going to sniff here on the far end where server is, and we're going to start a capture. I apologize. There's a ton of windows that come up with all this. So unless you have a really big screen, there can be a lot of confusing windows to pull up and look at. I'm trying to minimize the ones we're not using. If you look at the top here of Wireshark, it will tell you the link that it is sniffing. And I'm going to move them to each side so we can kind of see the same thing. And we'll pull up that one. And we will rerun the same ping that we did before. So you can see the packets are leaving from VPCS 1, but they're never arriving on the far end. They never get anywhere. And when we look, we can see the pink packets are the ping packets going from 202.50, which is VPCS 1, and they're going out to 54.100, which is the correct IP address. What we're seeing is a response come back from 202.254. Notice that it's in the same network. And when we configured VPCS, we told it 202.254 is our default gateway. And that IP address got configured on VyOS 1. So, what we're saying is, hey, VPCS 1 says, I don't know what to do with this packet. I guess that means I give it to my default gateway. The default gateway looks at it and says, I don't know what to do with it either. I don't have a route table entry for this packet. And so it's giving an answer back in the black and green saying, I don't know where this is. ICMP messages, as we can see in the protocol column, are Internet Control Message Protocol. So that's how we do sometimes ping in this case, but ping can also be UDP. But also when we get answers back from things like intermediate routers, we'll get an ICMP message back. And in this case, we're saying, I'm sorry, I don't know what that is. I can't get there from here. All right, so that on the blank one on the right side, we can see those packets never made it to the far end, which is what we would expect. So let's go and sniff maybe a little closer and see if we can't find something a little closer. So we'll stop Wireshark here on both of these, and we'll say stop without. There we go. And that stops Wireshark. That doesn't stop the capture. You notice the little magnifying glass stays. So we have to actually go and say stop capture, which we'll do here and here. Now we'll start a new capture in the same spot, so that way Wireshark's interface will be blank and it won't be quite as confusing. Here, and we'll open Wireshark with it. Ta-da. And we'll also go and sniff on the other side of the Ethernet switch. So this is a layer 2 Ethernet switch, so it shouldn't have anything to do with the IP addresses, but it'll tell us how far is this packet making it? How far in my network is it going? So that I can begin to tell. This kind of troubleshooting that we do is very common when we're starting to have problems and we're trying to look at where is the packet going, where is it coming from, how far is it making it in my network. We'll also often stick a probe in and start sniffing and looking. So, you know, am I having a switch problem? Am I having a router problem? Those kinds of things. And we can see when I sniff now, I'm still getting the network unreachable error, but those packets are going through that switch, which is what we expect. We expect the packets to leave VPCS1, go through the Ethernet switch, and go to VyOS1. And our packet captures confirm that. We can prove using packet data that's what's going on. And for my students, that's going to be useful because we're going to use that kind of data when it comes to labs. We'll be using output data. This is summary data, but down here we'll be using other data to begin to talk about to prove those kinds of things. Sometimes when I go and I'm making changes to the network and things like that, I will go and set up packet sniffs to be able to confirm that the network's behaving the way I expect it to behave, even if that's failing where I expect it to fail. I'm going to turn off all the packet sniffs at this point, and that way we'll have our network back. And let's go and set up some route entries in VyOS1 to begin to be able to find the other end. So this is kind of a multi-step process. We're going to want our diagram. You'll probably want your user guide page for it. You can see here we've got VyOS1, and that's our kind of configuration. And what we're going to wind up doing is we're going to add a static route, is what it's called, to go from VyOS1, and somehow VyOS1 needs to understand that there's networks beyond the ones it's directly connected to. And by adding route table entries, we tell it, hey, if you see traffic for this network that's not one of your locally connected networks, send it somewhere. Give it to somebody that might be able to do something with it. And in our case, we're saying, hey, you don't know about 192.168.54.0/24, which is the network that server is on. But if you see traffic for it, send it to ETH0 of VyOS2. Now, keep in mind, ETH0 of VyOS2 is a network that VyOS1 and VyOS2 share. So where the packets are going has to be somewhere that VyOS1 can directly see. Has to be a network and an IP address that can directly talk to. So to do that, we're going to go and give VyOS1 a set protocols, static route, and we're going to say, what network am I seeing? Now, when we did the subnetting lab, it was really important to understand what a network number was. This is why. We use these network numbers to route, and without them, we can't. So we're saying if you see any traffic that exists in the 54.0/24 network, so that's that range from 0 to 255, if you see traffic that's in that range, do something with it. And in this case, it's a next hop. So what's the next place I move it on to? When we talked about traceroute earlier labs, hops were all those little places that it hit down the list. So where do we send it? In this case, we're going to send it to VyOS2, but it has to be on the network that is shared between VyOS1 and VyOS2. It has to be a destination that's actually reachable on a local link level. And in this case, it's a specific IP address 192.168.103.100 is VyOS 2 ETH0's IP address. So we're saying if I see traffic for this whole network, send it to that specific destination. And if we do show, we'll see it's added in a whole new section. Protocol, static, route, breaks it all down. So we'll commit that. Now, this means outbound traffic will get to VyOS 2. VyOS 2 will look at it and say, ooh, I'm directly connected to that network if you're headed to server, and we'll pass it along. When server responds, right, a ping has a request and a response. When server responds, it will hand that traffic to VyOS 2, who will promptly say, I don't know what you're talking about. I don't know about any networks. So the traffic will get there, but it won't get back until we edit VyOS 2 to know about the network where our client is, VPCS1. So let's see what happens if we go and Wireshark that, and we'll be able to see the packet get to server. We'll see the response come back, but then it'll get dropped because we won't know what to do with it. All right, so to do this, we're going to want to sniff here at VPCS1 so we see the traffic going out. And we're going to want to sniff here at server. So this is pretty much the first thing I set up originally. And one of them opens Wireshark and the other one doesn't. It's magic. No one's quite sure why. If we don't get all the Wiresharks we need, we may need to go force them to open. And of course, we can look at the top to see where they're connected between. So I've got one there. Got one here. I will open VPCS, and again, we're just going to try the ping. And this time they go somewhere kind of weird. And that's not unexpected, it's just not completely there. We've got half a route, we got a there route, but not a back route. So what we're seeing is what's expected, right? The packets are going out. VyOS 1 is routing them and not kicking back an error because VyOS 1 knows what to do with it. So what we're seeing on the VPCS side is correct in terms of error messages. We, of course, don't see any responses, which is unfortunate. But when we look at what's going on with server, that's where it gets a little more interesting. So I'll expand that one. We can see the ping packets are coming in. There's the request. And we can see that server is replying to those. But when it goes to send a reply, it doesn't, VyOS 2 doesn't know what to do with it. So the reply is going back to 202.50, which is VPCS, and when server doesn't know what to do with it, it turns around and hands that to VyOS 2, because that's the default gateway for server is VyOS 2, and it hands those ping packets headed back to VPCS1 to VyOS 2, because that's the default gateway. And VyOS 2 looks at them and says, geez, I don't know. Now remember, we only edited the route table for VyOS 1, so VyOS 2 has no idea where the VPCS1 network is. We didn't tell it. And that's why we get these destination unreachable error messages on the server side of it now. And of course, there's no messages sent to VPCS1, neither the replies nor an error message. The pings just go off into the ether and disappear. We don't know where they go. So let's go fix that problem and we'll run the ping. So to fix the problem, we've got to put in a corresponding route back so that way everything can get home. So let's turn off our sniffs. And we'll turn off all our Wiresharks. There we go. Let's shut off Wireshark here. Come on. All right, and we need to go configure VyOS 2 to be able to drag the packets back to us. Because without that, there won't be any way to get home. And again, we're going to use the same command. We're going to say set protocols route static route. And we're going to say where we're going. So if we're sitting at VyOS 2, we need to be able to get to the one network we can't directly see. We're not directly connected to. So if we see traffic for 192.168.202.0/24. Now remember, the ping responses were headed for that network, and without this route, we couldn't get there. And we say next hop. And where do we send it? Well, we have to send it on a direct link. So it's got to be on, we're going to send it to VyOS 1 via the IP address that is part of the network VyOS 1 and VyOS 2 share. So in this case, it's 192.168.103.125 because that's VyOS 1's address on that network in between. All right, and we say show. And we can see we've added the route just like we saw on the other one. And we say commit. And there we go. So at this point, we should be able to ping and receive responses from VPCS1 all the way to server. And there we go. We get nothing. I got screwed. So it's a little frustrating here. The first time, the first 2 times we pinged didn't go anywhere, but we can see that the third time it did ping right before I hit Control-C and stopped it. So I was doing a little investigating and I figured out that, yeah, it did ping. And if we go down and look, we can see that there's a bunch of pings that go on. And it just takes the switches a little bit to figure out what's going on and the routers a little bit to figure out what's going on. And sometimes we drop a couple packets on the way there as things are trying to figure themselves out from one end of the network to the other. And that's not uncommon. Networks are a dynamic thing. They change around. They can take a little while. That's why we send more than one ping, because they can just go off into the Ethernet and be lost for a little while, and those packets get dropped. You can see here I've done it repeated, and it seems to pick itself up. So let's do a quick Wireshark on both ends, and we'll be able to see that it's doing what we think it's going to be doing. There's one Wireshark. There's one end. We start the second Wireshark. Magically, we decided to start 2 Wiresharks this time instead of last time when we didn't. No one can answer. It's magic. Okay, so there we go. Now we've got everything set up, and we'll do the ping. There we go. We can see end-to-end communication. We're seeing echo requests and echo replies on both ends. That means both routers are routing in both directions. Okay, so this nugget was super long, and I apologize for that. We did basic network routing. There's going to be advanced labs at a later time where we'll go over default routes in VyOS. We'll add some connection to allow it to get to the internet, so that way our PC and our server can both get out via the default routes to the internet. But that will be saving for a more advanced lab when we've got some other concepts under our belt like DHCP and NAT and some other things like that. But for now, keep an eye out. There'll be more tech nuggets. Have a nice one.